Hi everyone, my name is Giovanna Proença and today we're going to talk about problem set 0 degrees of CS50 Introduction to Artificial Intelligence with Python. If you would like to have full support from a programming expert, check the description below. And we would like to emphasize that this video solution is made for those who have already completed the assignment and want to have an alternative view about the problem. We totally discourage plagiarism. So in this problem set degrees, we're gonna write a program that determines how many degrees of separation apart two actors are. So for example, in this case, we wanna know Emma Watson and Jennifer Lawrence. And then we're gonna check how many degrees of separation they have. So for example, here we're saying 3 degrees of separation because Emma Stone worked with Brandon at Harry Potter, then Brandon worked with Michael in Trespass Against Us, and then this Michael worked with Jennifer Lawrence. So we're gonna check the relationships between these two actresses, and then we're gonna find what is the degrees of separation. Okay, so everything in here will be based on the lecture 0. Okay, so if you remember, we have the depth first search as they mentioned in the lecture 0. Basically, a depth first search algorithm exhausts each one direction before trying another direction. In these cases, the frontier is managed as a stack data structure. The catchphrase you need to remember here is last in, first out. So it's like a stack, not a queue. All right, so a stack here, the first one it enters will be the last one that will be out. Okay, after nodes are being added to the frontier, the first node to remove and consider is the last one to be added. This results in a search algorithm that goes as deep as possible in the first direction that gets in its way, leaving all other directions for later. So it's like we're gonna search all the branch. You can think about a tree. We're gonna search all this branch and then we go back and search the other one if we have 2 ways of searching. Okay, we're gonna understand better with this animation here. A frontier is a data structure where you can store the nodes you're exploring. We will start from A in the frontier. The first thing we will do is add the node to the explored set. In this case, we're going to start from A. According to the algorithm, after we started with A, we need to remove A from the frontier, add to the explored set, and add the neighbors of A to the frontier. In our case, we will add B to the frontier. Then we will add B to the explored set and add the neighbors of B to the frontier, in this case C and D. According to the algorithms, we should always be checking if we are at the goal state. If we are at the goal state, we're done. Now we're going to remove D from the frontier and add to the explored set. Then add the neighbors of D in the frontier. In this case, only F because F comes after D. Then we will put F in the explored set. Since F has no neighbors, we go back to C, which is on the frontier. We add C in the explored set and add the neighbors of C to the frontier, in this case E. Finally, we will add E to the explored set, and since E has no neighbors, we're done with the search. So basically we're gonna use this depth first search, okay, to help us working with the code. And in the future we're gonna use another resource that we saw in the lecture to help us completing the degrees.py. Okay, so let's see the specification, have all the things we have to do in our hands, and then we start seeing the code and solving. Okay, so here complete the implementation of shortest path function such that it returns the shortest path from the person with ID source to the person with ID target. So basically we're gonna create this function here, shortest path. Alright, assuming there is a path from the source to the target, your function should return a list where each list item is the next movie ID, person ID pair in the path from the source to the target. Each pair should be in a tuple of 2 strings. So basically in here we want to create this logic here of saying Emma Watson and Brendan Gleeson started in Harry Potter. So we want to know what is the person, we have the relationship here, it's Brandon, and what is the movie. movie, and then in the end our code already have some code to print exactly what is the name of the actors and the name of the movies. Okay, so that's why we need this tuple saying what is the actor we have a relationship and what is the movie that they started together. Okay, if there are multiple paths of minimum length from the source to the target, your function can return any of them. If there is no possible path between two actors, you should return none. You may call the function neighbors for person function, which accepts a person's ID as input and returns a set of movie ID, person ID pairs for all people who started in a movie with a given person. So here, these neighbors for person, it's going to return us. Do you remember the animation? It's going to return us who is the neighbor for the letter A. So it's letter B. And here, instead of letter A and letter B, we're gonna work with the tuple movie ID and person ID. Okay, one thing that is important to notice is that here they are telling us that you're welcome to borrow or adapt any code from the lecture examples, and we're gonna do this. Okay, don't worry. We've already provided you with a file util.py that contains the lecture implementation for Node, Stack Frontier, and Queue Frontier, which you're welcome to use and modify if you like it. Okay, so basically we're gonna use the maze.py, the code that they gave to us. Actually, this will be pretty much this function in here with a little bit of differences, but we're gonna see this in a bit. So now let's understand what we have in our hands. So here in util.py we have the class node. So the node creates an object here that will contain the state, the parent, and the action. Alright, the stack frontier here, it's pretty much what we saw in the lecture, and the queue frontier as well. Okay, just remember the main difference. A stack is the last in, the first out. Yes, the last in, the first out, and the queue is like a regular queue, first in, first out. Okay, and then we have the degrees.py. So basically in here we already imported the node, stack frontier, and queue frontier. We have here the load data, so we're gonna load the CSV file into the memory. Okay, and remember that in the CSV file we have movies.csv, where we contain the ID, title, and year. We have the people.csv, where we contain the ID of the person, the name, and the birth. And we have stars.csv, where we contain this relation between the person ID and the movie ID. So we know that, for example, Emma Stone did Harry Potter. Okay, this is where we have the relationship. So in this function we are reading this data. All right, we're loading all the CSV files and we're storing in our data. So here on line 65 we have the first name in our example, that in here we know that it's Emma Stone, and this line 68 will get the second name we want to know, so it's the target, and it will be Jennifer Lawrence, for example. Okay, so here's the source, here's the target, like we're seeing here. Then we're calling the shortest path, and we're gonna store here in a variable called path. Okay, so in here we're going to we're gonna create this function, and later on whatever we return, it's going to return us they're gonna create this 3 degrees of separation and what are the actors and the movies they started. Okay, then we have the shortest path. We're gonna work with this function. We have person ID for name. So here basically we're checking. If you take a look, person ID for name here, this is a function that it's being called with the input that we're gonna pass. So basically this person ID for name, we're gonna check if the name of the person that we gave exists in our CSV file. So for example, here if I put Anna Watson instead of Emma, we would return here a message source is none. Okay, we would return the correct thing. So this function is just returning as if the person exists or not. Okay, and it's returning as the ID, but basically it's checking if the person exists or not. And the neighbors for person returns movie ID, person ID pairs for people who started with a given person. So here we're receiving the neighbors for the node that we are in at that moment. Okay, so this is pretty much what we have in our hands. Now let's start implementing the shortest path. So here in the shortest path, what is the comment that we have? Returns the shortest list of movie ID, person ID pairs that connects the source to the target. If no possible path, returns none. So basically here we're gonna get the shortest list, the shortest degrees that one person has to another. Okay, for example, Emma Stone and Jennifer Lawrence has 3 degrees of difference. Okay, so to do this, we're gonna take a look at this code in here, this solve function in the maze.py, like I mentioned earlier. So basically here, it will find the solution to a maze if one exists. So we're gonna practically do the same thing as we have in here. So let's see every part together. So first, keep track of number of states explored. So this is mandatory from our algorithm. Okay, we need to set this. So I'm gonna put in here. Let me remove this to do. Okay, and like CS50 told us, we can reuse many parts of the code in our problem. Okay, then let's see in here. Initialize frontier to just the starting position. And let me copy this because we're gonna use, and then I'll do some changes. Okay, so here, initialize frontier to just the started position. Okay, so here we're creating the start variable, and here we're using the node. Remember, the node is a structure that we got here from the util.py. Okay, and this node here we have state, self.start, parent none, and action none. In our case, we're not going to use self.start, okay, because we know what is the start of our node. So here the start is the source. Okay, that's why we are receiving this variable source. So here we're going to use source. Okay, then we have this frontier, stack frontier. In my case, I want to do a queue frontier, so I'm gonna replace here to queue frontier. All right, and then frontier.add start. So remember, the first thing we have to do is adding the source of what we're looking for in the frontier. After we add in the frontier, we're gonna add this in the neighbor. Then after we start with this node in the frontier, we're going to remove from the frontier and add in the explored set. And at the same time we're adding in the explored set, we're going to add the neighbors of this node in the frontier. So it's always this cycle. Okay, so right now we're adding the start in the frontier. Then initialize an empty explored set. So let's initialize here an empty explored set. Okay, this is something that we need. And then let's see the next part. Keep looping until solution found. So this is something that we have in the algorithm as well. We need. Okay, something else that we need in here, if we take a look. If nothing left in frontier, then no path. So here it's when we have no solution. Okay, so we're gonna have this if frontier.empty raise exception no solution. So we're gonna use this as well. And choose node from the frontier. This is something that we need as well, because remember, what is the cycle? Get one node from the frontier, put in the explored set. Okay, so we are removing from the frontier and we're adding the explored set, and then we're going to add the neighbors in the frontier and keep going. Okay, so these parts in here we're going to work. Okay, let me fix the indentation of all of them. Perfect. So far we're just reusing what we saw in the lecture. Okay, then let's see. Here it's saying if node is the goal, then we have a solution. This part we're gonna do later. Okay, this will be a little bit different from what we're seeing here in this structure. So the next step we're gonna do is mark node as explored. Okay, so we're removing from the frontier like we did in here, and we're gonna add in the explored set. Okay, this is what we have so far. So let me see some differences that we have to do. Here we have frontier, we're gonna raise an exception, node frontier, and here we're gonna use num of explored set. And one thing that is important in here is that we're not gonna use self. Okay, here's just a num of explored set. Here the explored will be without a self. Okay, we're gonna remove all these selves that we have in here, and here again we're gonna remove the self for both of them. Okay, So these are the little changes that we have in here. Now we're going to work with adding the neighbors to the frontier and finding the goal solution. So let's think about it. So now we're gonna work with adding the neighbors in here and continue with our algorithm. Okay, so we're gonna do a mix. We're gonna use this part, and then inside this part we're gonna add the checking if we find the goal or not. Okay, so let's copy this and we're gonna do the changes that we need. So after adding the explored, the initial state in the explored set, the source in the explorer set, we're gonna do the following. Here for action and state, what is our action? The action is the movie ID, okay, and the state is the person ID. All right, and what will be the self.neighbors? First, let's work with this. The self.neighbors will be the function neighbors for person, and we have to pass the person ID. So here we're gonna call the function neighbors for, let me copy all of this and this will help us. So we're gonna call this function because this function will give us all the neighbors that we have in here. Okay, and instead of person ID we're gonna use node.state. Okay, because what is node.state? Here we created the node and the state is the source. Okay, that's it for now. Let me just double check one thing. Okay, then what we have to do here, these neighbors for person, we're gonna receive in here the neighbors, and the neighbors will be a tuple where we have movie ID and person ID. So we want to do a for loop getting the movie ID and the person ID. Okay, so here instead of action we're gonna have movie ID, and for person and for state we're gonna have person ID. Then we're gonna use this if not frontier.contains state, and here we have the word state, and remember every time we have the word state we're gonna change for person ID. And state not in self.explored, and here instead of self.explored we're gonna just use the word explored. Okay, because this is the name of the set we have in here. All right, and what is this frontier dot contains state? If you go here to util.py we have this function that we're getting from the stack. Here actually I think I made a mistake. We're not using a queue, we're using a stack. Okay, let me change here. It will be a stack. All right, so everything I said before it was wrong, so here is a stack. And now let's create the child. So what will be the child? The node here we're gonna use the person ID that we're looping. Okay, the parent is equals to node, and the action will be the movie ID that we're looping as well. Okay, now we're not gonna add the child in the frontier. Now we're gonna check if we find the goal state. Okay, so now we're gonna grab this part here and we're gonna do the changes that we need. So I'm gonna paste in here. Let me fix the indentation for all of them. Okay, and this is it. So now we need to do some changes. Here, if node is the goal, then we have a solution. So instead of node, it will be the child. Okay, because now we're working with the child. So if child.state equals self.goal, so in our case it's not self.goal. The name of the goal here in our function is target. Okay, so we're gonna use the word target because we're looking for the target, in this case for example Jennifer Lawrence. Then we have actions. We're creating a list for actions, but in this case the actions we can call movies because this is what we're calling instead of actions, and the cells we're gonna call people. Okay, and I also want to create one list for the solution. Okay, so I'm gonna write in here solution equals to a list, and this solution we're gonna see in the future how it's going to work. So now we need to check while node.parent is not none, so instead of node we're working now with the word child, and while this is not none we're gonna append in our movies. So remember here it's not actions anymore, we're gonna change to movies, and it's not cells anymore, we're gonna change to people. Okay, and we're gonna append not node but child in both cases because we're not working with the word node anymore, so here it's child. Then we're gonna create a new node for the parent, so here child will be equals to child parent, so this way we go for the next child we want to work. And here we need to reverse the order of the movies and people. You have to think why we have to reverse. We have to reverse the order of solving the problem, because here we don't want to we want to print exactly this way, from Emma Stone to Jennifer Lawrence, not the other way around. That's why we're gonna do first Emma Stone, Brandon, then Brandon with Michael, and then Michael with Jennifer Lawrence. So that's why here we need to reverse. And again, here actions is movies and cells we're calling people. Okay? And in the end, so here it's a little bit different. We're not gonna have this self.solution, okay? And we're not only gonna return. Here, instead of self.solution, we can take a look here in what they're expecting us to return from this shortest path. So basically, the shortest path is a function such that it returns the shortest path from the person with ID source to the person with ID target. So here we want to return a tuple, like we can see here. For example, if the return value of a shortest path where it's a list where we have the tuple here 1, 2, 3, 4, okay, that would mean that the source started in movie 1 with person 2. Person 2 is starting in movie 3 with person 4, and person 4 is the target. So here we want to add them as a tuple in a list, okay? So how can we do this? We're gonna use the zip function and we're gonna loop, okay? So how can we use the zip function? We're gonna create a variable here we can call x, for example, and we're gonna use the zip function, okay? And the zip function, we're gonna add the tuple. And what will be our tuple? Will be our movies and our people. Here we're adding the two lists that we are receiving. And then we're gonna loop through this zip. So we're gonna loop through this zip where we have movies and people, and we're gonna append the solution in here. So we're gonna do for movie person, for example, in X, okay? And we're gonna add a solution list to return in the main function, okay? So we're gonna do solution dot append, and what we want to append the movies and people tuple. Sorry, movie and person tuple. And in the end, we want to return solution. Okay, this is pretty much this that is going on. I just need to check if we have to import zip. No, we don't need it. So let's try it out. Let's see if it's working. So if I run in here python degrees.py small, and I put here like Emma Watson, and I put here Jennifer. Let me see what is her correct name. Jennifer Lawrence. And I put here Jennifer Lawrence. And we enter. This is saying person not found. So let's see why. I think we don't have Jennifer Lawrence in here. I'm gonna put another name like Kevin Bacon and Tom Cruise, for example. Let's run with Kevin Bacon and Tom Cruise. So if I run in here Kevin Bacon and Tom Cruise, it will load, and it's saying name state is not defined. Did you mean start? So let me review a little bit about the code and then we do some changes. So in here, something that is important is we were using state, but here should be person ID, okay? And now let's try it out. And we will probably have one issue here, but I want you to take a look what is going on. So let's do with this small. If I put here Kevin Bacon, for example, Kevin Bacon and Tom Cruise, it will find 1 degree separation really fast, and that's it, okay? But now let's try it out with a large. Let's use the example that we have in here, this example of Emma Watson and Jennifer Lawrence, okay? And you're gonna see here why we should use stack or why we should use queue from tier. Here we're gonna see the difference and we can manipulate. Remember that we were working with stack in here, but we want to change in the future for the correct one. So here if I put here Emma Watson, for example, and Jennifer Lawrence, and let's see. Here it's giving us a bunch of movies they worked together, right? But we should receive the smallest degree. We should receive only 3. And this is happening because we're using stack from tier, okay? So what if we use queue from tier in this case and we run it again? Let's see what happens. So if I put in here, we have to wait a little bit to load the data, and then we can work with the correct ones. I remember I said in the beginning we should use Q, and then I changed to stack, but the correct one was Q. But here I wanted you to take a look why it is important. Here Emma Watson, and I put here Jennifer Lawrence. And remember that right now we're working with Q frontier. And in this case, it's giving us only 3 degrees. This is the correct answer. Okay, so we should work with Q frontier instead of stack. Okay, and like you can see in here, it's giving us different movies that they work it. All right, here we're seeing like Harry Potter and X-Men, and here we are receiving like Noah, Boy Erased, and Red Sparrow. And that's okay because this depends on which path the shortest path worked to find in here. So it's working. We got here everything correctly. All right, so this is it for our code. I don't think we have a check 50, right? But I will submit, and then we can take a look at the grade that I took. Let's wait a second. One thing that I forgot is that here in CS50 AI, if you take a look, they're only gonna give us the grade after some time. All right, it may take up to 3 weeks for your submission to be graded, so we can't see if we're correct or not. But you can test, and you're gonna see that in any testing you're gonna do, you're gonna get the correct degree. Okay, and that's it for our code. So now that we finished the problem, we're gonna see what is going on inside of our code. Okay, so we're gonna use the debugger. So to do this, when you wanna try to run a file where you have to send variables from the command line, you have to work here with the launch.json. Okay, and you have to add here this key value pair. So you have to add the key called args, and inside this list here you're gonna put the arguments you're gonna add in your command line when you have to run your code. Okay, in my case I put here the path to find the small folder. So if we take a look in here, it is inside the CS50 AI, that it's inside degrees, and inside degrees we have small. Okay, so now let's run our debugger. So what will be the case I'm gonna test in here? I'm gonna run, and I will try this case here where we wanna find Kevin Bacon and Tom Cruise. And why is that? Because we know that we have only 1 degree of difference, of separation between them. Okay, so I'm gonna put here Kevin Bacon and Tom Cruise, and let's see what happens. So what are we receiving here? If we remember, in the shortest path function, we are receiving the variable source and the variable target. And what are them? Are the IDs of each person we're looking for. So 102 is the ID for Kevin Bacon, that is our source, and 129 is the ID for Tom Cruise, that is our target. Okay, so in our line 96, what are we doing? We're keeping track of number of states explored, so we're creating here a variable to keep track of this, and so far we have this variable num explored equals to 0. Okay, and we're gonna initialize the frontier to just the starting position. So what is our starting position? Is Kevin Bacon, okay, our source. So in here we have the variable start, and this variable start will be a node where we have state equals to source, so the state will be 102, parent will be none, and action will be none. Okay, and once we click in here, we're gonna find now our start variable, that it's a node object. Okay, and we have action none, parent none, and state 102, like we were expecting. Then we're gonna create a frontier using the Q frontier, and when we take a look in here, we have a frontier Q frontier, and our frontier is an empty list so far. Okay, after the line 101, we're gonna add this start variable, so the first node we made inside the frontier, and this is the first step of our algorithm. Okay, so now in our frontier, like we can see, we have 1 node inside. Then we're gonna initialize an empty explored set, so we're gonna create now the explored set. Remember that in the algorithm, in the depth first search, we work with the frontier and the explored set. Okay, so now we're gonna start working with the algorithm. So we're gonna loop until the solution is found. Okay, so here we're doing a while loop, and let's take a look at what we have. So basically here we have the explored set that is empty. We have the frontier that right now we have 1 node. We have the source, and we have the node that is the start. Okay, and the target. So now let's go to the next line. 110. So we're gonna check if the frontier is empty, because if it's empty, this means that we have no path to look anymore. okay? So in this case, we can take a look at our frontier, and the frontier is not empty. We have one node here inside, so we're going to skip this if condition. Okay, and we're going to start working with the algorithm. So the first thing we need to do is we're going to remove the node from the frontier and add in our explored set. So we're doing this, we're creating a variable called node, and we're going to remove from the frontier. And take a look in here in the debugger. Once I run this line, our frontier will be empty again. Okay, it's empty again. All right, and we created a variable called node. Where is this variable called node? Let me see. We created a variable called node in here, and this variable called node, it's exactly what we have in the start variable. Okay, then we have to keep track of how many nodes we have in the explorer set, and here we have only one. That's why we're going to do +1. And since we removed the node from the frontier on line 114, we need to add in the explored set. So this is what we're going to do. Once we run this line, our explored set won't be empty anymore. We'll have the person ID. So now we have the ID of Kevin Bacon, 102, okay? Now, the next part of our algorithm is to look for the neighbors of our node and add these neighbors in the frontier so we can keep our algorithm in here. So, for this case, we're gonna use this neighbors for person function, and once we run it, we're gonna see here the result for neighbors for person. As we can see in here, we have 8 neighbors for Kevin Bacon, okay? And here we have the ID of the movie and the ID of the person. So we're gonna loop through this until we find the ID of the target, okay? The ID of Tom Cruise. And we can see in here that we have the target is 129, and here we have 129, okay? So basically we can understand what is going on. So for the first loop, what is our movie ID? The movie ID is this number, and the person ID is this number here, 197. So we're gonna check if 197 already exists in our frontier. Since our frontier is empty, we're not gonna enter this if condition will be true, this part of that the person ID is not in the frontier, and we have to check if the person ID is not in the explored set. And our explored set only have the number 102. So this if condition will be true, and we're going to line 123. In here, we are creating a variable called child, and we are creating a new node where the state will be the person ID, the parent will be node, and the action will be the movie. So once we take a look in here, we have now a child, okay? And this child has this ID of this person, okay? So we're gonna check, is 197 equals to the target? So 197 is equals to, let me not expand this. So 197 is equals to 129, that is our target. No. So we're gonna skip this if statement, and we're gonna add the child in our frontier. Okay, this child in our frontier. So now, if we take a look in here, we have this child in our frontier. All right, we have one item. Before it was empty. Now we're gonna loop again, okay, and we have now the person ID now. What is the person ID? It's 200, okay? So we're gonna check. 200 is already in the frontier, so 200 is not in the frontier, okay? And 200 is not in our explored set, so we're gonna enter in this if statement. We're gonna create a child, and here the child, it is created, and we're gonna check. 200 is equals to 129, that is the target. No, so we're going to skip this if statement, and we're gonna add in the frontier, okay? Now we're gonna loop again, and now let me see here one thing. So now we're gonna loop again, the person ID is 158, and we're gonna see, 158 is already in our frontier. No, okay, it's not in our frontier, and it's not in our explored set. So we're gonna enter in this if statement, we're gonna create a child, and we're gonna check if, what is the number of this, the child? We're gonna check if 158 is equals to 129, that is the ID of Tom Cruise, so this means this is not correct, they are not the same number, so we're gonna add in the frontier. Okay, so far we have 3 elements in the frontier right now. Now we're gonna loop again, the person ID is 158, and we're gonna check. So 158 already exists in our frontier. No, Okay, our 158 does not exist in our frontier, and it's not in our explored set, because if we take a look in here, the explored set, we have 102. Now, let's see this particular case, because now this will be really interesting. Our person ID right now is 129. Okay, so 129 is in our frontier. It isn't. Okay, it's not in our frontier. If you take a look in here, it is not. And it's not in our explored set. Okay, it is not. So we're gonna enter in this if statement. We're gonna create a child. Okay, we're gonna create a child where we have the we're gonna create a child right now, sorry, where we're gonna have the ID 129. So now it's the important thing we're gonna look, okay? This is something new. So 129 is equals to our target, that is 129. Yes, so we're gonna enter in this if condition, okay? Now I'm going to show some things. In line 127, we're creating the movies list. Okay, so our list will be empty. Here, movies list empty. We're gonna create a people list empty as well, and a solution list empty as well. So we have 3 lists. Now we're gonna check, we're gonna do a loop. While child.parent is not none, so what is our child? Our child is this one, and what is our parent? This is our parent, okay? 102, and we have parent none and action none. So we have one parent in the child that we're working. So we're gonna do a loop, okay? What we're gonna do first, we're gonna append the child action. So what is the child action? Is this movie 10:42:57, so we're gonna append this movie. And we're gonna append the person, so we're gonna append 129 in here, okay? So in movies, we're appending the movie ID, and in people, we are appending 129. That is the target we're working right now. And then we're gonna change our child for the parent of the child. So our new child will be this node here, there is the parent, okay? So when we run in here, now we change here the child, and it also changed the action and the parent. So basically now our child is not Tom Cruise anymore, now it's Kevin Bacon again, okay? And we're gonna loop again. So while child.parent is not none, right now child.parent is none, right? So we're gonna stop this while loop. Okay, we stop this while loop, we go to line 134, and we're gonna reverse the list movies. In this case, since we only have one item, it won't change anything, but if we have more items, it would reverse the order of the list. Then we're creating a variable x that will be a zip of the movies list with the people list. So let's see x in here. Where is x? If we scroll down, x here is a zip object that contains both lists, okay? We cannot see, but it's okay. We're gonna see right now in the loop. And we're gonna do for movie person in X, so what will be movie and person? Movie in here, like we can see, is the movie, it's the first item of our list, and person will be the first item of our list of people. And we're gonna create a tuple here to append in our solution. Okay, so we're adding here the solution, this tuple, the movie ID and the person ID. Then we're gonna loop again, but we don't have more items in both lists, so we're just gonna return the solution, and this is it for the code, okay? I know it took some time to use the debugger, but it's really important that you check step by step what is going on. I highly recommend you to do this for other examples, for the large CSV as well. Okay, try to do this until you really understand what is going on, all right? So, if you enjoyed this content, please give us a thumbs up, subscribe to our channel. If you have any comment, any question, send here on the comment. You can check the description, and there you're gonna learn more about how can you have 24/7 support from a programming expert, okay? And I hope to see you in the next video. Bye bye. If you would like to have full support from a programming expert via Telegram group and group coaching, check the description below.